Welcome to the Learning Pines YouTube. We hope this video helps.
You start by defining scope and constraints. This guides every choice. Choose a model size and compute target because you must balance cost versus capability. Once done, provision GPUs, storage, and a minimal dataset of clean examples to iterate fast. Make sure to initialize a Git repo, container environment, and an experiment tracker so you can reproduce runs and compare changes. These first steps get you into training quickly and prevent wasted cycles later. You now construct the core: tokenizer, data loader, and model definition. Tokenize with a byte-level or sentence-based scheme to avoid unknowns and pipeline data for GPU throughput. Next, choose a transformer variant and optimizer. These choices affect stability and speed, so tune warm-up, decay, and weight decay. Once done, train progressively: short sanity runs, then longer passes with gradient accumulation and mixed precision to use memory well. Monitor loss, perplexity, and you finish by fine-tuning on labeled data and optimizing inference settings like temperature and beam size so outputs match your goals. Then package the model with its tokenizer and tests, containerize the stack, and deploy to a serving endpoint with auto-scaling. If things go wrong, first inspect data quality for leakage or label errors, then verify gradients and learning rate schedule for instability. Also profile I/O and batching. Most real-world failures trace back to bad data, hyperparameters.
Thanks for watching. Consider subscribing if we helped you.